Okay, good morning. Welcome to Math Project 87. Today we have a kind of a tricky geometry picture. Usually we did these with Duplo blocks, but we're going to try it on the big whiteboard and see. So even though the picture is not super good, we'll try to do the best we can. Okay, so in the figure above, all the small rectangles are the same size. So even though they're not drawn all perfectly to be the same,
yeah,
all these ones are the same size.
We're just pretending they're the same.
We just pretend they're the same size. Usually when you see one of these problems in a book, they're drawn a little bit better. If the width of each small rectangle is 2, what is the area of the big rectangle? Okay, so now we actually have I didn't think about this for having you take a look at this. I'm going to have to get you a chair to stand on. I should have drawn the picture a lot lower, shouldn't I? Hold on. Let me go get a chair.
That's better.
Okay. Now you can actually look at this picture. Okay, so the first thing I want you to do is on a problem like this, I want you to off to the side. I want you to draw.
Oh yeah.
Well.
Were you?
No, up.
You?
Kind of by where your head is. Up here. Draw one of the small rectangles. Okay, and what's 2? Label on that rectangle when it says on your small rectangle when it says the width is 2. What is it talking about?
This side.
Yeah, the width is 2.
This is 2.
Okay, great. Great. Okay, and what is the length of the small rectangle?
Well, we don't know.
Okay, so what do you want to call it?
Call that x.
Call that x. Okay.
So the width is 2 and the length is x.
Okay. So now, what do you think the next thing we need to do to solve this problem? Because we're trying to figure out the area of the big rectangle.
Well, we can call our width y.
Well, we know what the width is. What's the the width of the big rectangle? You mean? Call it y?
Yeah.
Ah, okay. Sorry, I misunderstood. I misunderstood. Let me get a different marker here. Okay, so we can call. I'll help you draw. We'll call this y. And what do you want to call the length of the big rectangle?
X.
Well, you already used x for the width of the
z.
Z. Okay. Okay. Let's go to z.
Is the ceiling a whiteboard?
No, the ceiling is not a whiteboard. You cannot draw on the ceiling.
It looks like one.
Yes. Yes, it does. But please don't draw on the ceiling, because then you'll find out that it's not. Okay, so the length of the big rectangle is y, and the width we're calling z. Now, what do we need to figure out to calculate the area of a rectangle? What do we need to figure out to calculate the area of a rectangle?
The area of a rectangle is length times width.
Okay, great.
Maybe this color doesn't erase very well.
No, I know, this color does not erase very well.
Do you need a tissue?
Yeah, I got it, don't worry. I'm going to back you up just a little bit. Okay, no, step back, just...
Whoa!
Whoa! Okay, great. So, we need to figure out the length times the width. Length times width. Okay, so what is the length of this?
We're calling it z.
We're calling it z. Okay, so the length times the width is z times what's the width?
Y.
Y. Okay. And can we figure out what z is? In terms of our small rectangles?
Well, this short side over there is 2.
2, great.
And then we have 2x.
X.
And another 2.
X. 2. Okay. And what about how tall is the rectangle?
In terms of 2's and x's?
Well, yeah, in terms of 2's and x's.
Well, we got 2 and an x.
2 and an x.
Well, now we know that 2y equals z. because it's exactly half.
Oh, interesting. Ah, okay, so that's a great observation. Okay, we just learned that 2y equals z because y is equal to x plus 2, and z equals
2x plus 4.
So z equals 2x plus 4. That's a great observation. Okay?
Z is 2x plus 4.
Okay. Z is 2x plus 4. Okay, so 2y equals z.
How does that help us figure out the length of our small rectangle?
Well, we almost have it figured out. This is a great observation. But what about down here? What's the length across down here?
Well, it's 3x.
X plus x plus x. Okay, so we know that x plus x is the length.
Well, and that's the same distance as z.
Okay, so what was it up on the top?
Well, it was 4 plus 2x.
Okay.
Well, that means x equals 4.
Well, hold on a second. 4 plus 2x. That's how long it is on the top. And what does that equal?
And 4 plus 2x equals z.
Equals z. What else does it equal besides z? What does the
2y.
2 plus x plus 2, which is 4 plus 2x. What else does this equal?
It also equals 3x.
Equals 3x. That's the important thing that it equals. So the top is the same as the bottom.
Yeah.
So 4 plus 2x equals 3x. So that says 4 equals what?
4 is the length of a small rectangle.
4 plus 2x equals 3x. So 4 all by itself equals what?
Equals x.
Equals x. You move the 2x over to the other side, so you get 4 equals x. So now we know that x equals 4. Okay? And what was x, by the way?
X was length of a small rectangle.
X was the length of the small rectangle. Okay? So all of a sudden, we now know for the big rectangle, how long is the big rectangle?
The big rectangle.
How long is it?
The length of it is. It's 12.
It's 12. 3x, and we found out that x was equal to 4.
Well, then that must the width must equal 6.
The width must equal 6. Very good.
Now we have to do 6 times 12.
Okay, so the area is 6 times 12. And what is that? What is 6 times 12?
Well, I want to do 6 times 10 and then 6 times 2.
Okay, that's fine.
Well, 2 times 6 is 12 and 6 72.
72. Okay.
So the area is 72.
Okay, so why don't you hop down from the chair? Okay, so let me...
It's hot up there.
Yeah, it is hot up there. You're right up by the lights. So let's just review real quick. So we were told in the beginning that we had all these rectangles.
Yep.
Okay, and they were the same size.
Yep.
Okay, and so what we did is we figured out that the big rectangle had a couple different things that were the same. We know that the across the top is the same as across the bottom.
Yep.
And that meant that 3x was equal to 2x plus 4. And that helped us figure out what x was. Okay? Now, it could also have been the case that we could have used how tall the rectangle was or how wide the rectangle was to help us solve for what x was. This side was x plus 2. What's this side over here?
You mean the
How tall is the rectangle over here?
x plus 2.
X plus 2. So that doesn't help us, right?
No.
We're trying to figure out what x is. The problem told us that our small rectangles were too high, but it didn't tell us how wide it was. But saying that x plus 2 equals x plus 2 doesn't help, because that's always true, no matter what x is.
Even x is a billion.
Yeah, even if x is a billion, x plus 2 is the same as x plus 2. But this way did help us solve it. 3x equals 2x plus 4. The only way that's true is if x equals 4. And if x equals 4, we know we got 12 across the bottom and 6 across the top. Now, one other thing real quick. When x equals 4, our small bricks have sides 4 and 8. Oops, sorry. 4 and 2. Okay, so what's the area of our small bricks, small rectangles?
4 times 2 is 8.
8. And how many rectangles are there up here?
And there's
1,
2, 3, 4, 5, 6, 7, 8, 9.
Okay, if each one has area 8 and there's 9 of them, what's the total area?
8 times 9 is 72.
8 times 9 is 72. That's another way to do it.
Homework problem.
Okay, you ready to learn what the homework problem is?
Yippee, yippee,
It is Olympiad 78, problem number 2. Okay, Olympiad 78, problem number 2. Okay, thanks for watching.